resolve my sound issue.
All right, good evening, everybody. My name is Sean Quinlan. I'm from the Endurance International Group. EIG is a online web hosting solutions provider. So we primarily target small businesses, small contractors, that kind of thing, and provide them tools to get their businesses online. Have a website, have a shopping cart, have a blog, whatever it is they want to do. We have domain leading sites, which is what we call them, which is for some of our customers aren't so much hosting as they are buying and selling domains. We are partnered with Google in a whole bunch of different endeavors. We are international. We have offices all over the world. One of the things you guys may have heard, the Get Your Business Online ads by Google, and they're doing that campaign in countries all over the globe, and it's where Google goes out and does sort of free tutorials, workshops for small businesses to come in and get a free domain and a free website, and initially. And it's sort of a couple of hours of intensive, like, bring us some pictures and your idea for your website, and we'll help you get it online as fast as possible. And we're one of Google's partners for how they deliver those web services. We're actually made up of 4 primary platforms. Our 3 main hosting platforms are VDEC, which is a homebrewed website management tool, which has brands like iPower, Dotster, Domain.com, Fat Cow. Those are all different brands that we market under. We also own HostGator and Bluehost. Those are other brands under our umbrella. They're both cPanel, WHM, and cPanel based hosting. So all 3 of those platforms are Perl-based. So Perl is the primary language for the vast majority of our company's operations on multiple different platforms. We also have a company called DirectEye, which is out of India, which primarily does domain hosting, so they're sort of like a competitor of Enom. They do domain registration tools, they have domain reseller accounts, but they also do some hosting. And some other services as well, and we're actually using them as our primary hosting platform potentially for India and Asia, since they're located in India and have a lot of expertise in that area and a lot of inroads into those markets. They are Java-based primarily, which is going to matter in a minute as we talk about some things. So EIG's been around for a long time. EIG's almost 20 years old now. HostGator and Bluehost both have been around for a bit. We all have some massive stacks of legacy code, like any company that's been around for quite a while, which means in the Perl world, yes, we have servers that are still running 5.6 that we can't turn off yet. So our legacy stack is a little painful to maintain in places. It's our primary stack is 5.8.8 and has a bunch of old versions of modules that we can't upgrade because they break things like our credit card processor. So until we refactor our code and move off some of those old legacy services, we're sort of stuck. And like any place you work, you're going to have some legacy stuff to maintain, and you do the best you can with it. But going forward, we didn't want to stay there.
Wait a minute.
Where'd we go?
There we are.
So going forward, we didn't want to stay there. And we had new partnerships, like our partnership with Google. We had new services that we wanted to provide. We didn't want to do these in the legacy platform if we didn't have to. So the first one that we're going to talk about is Google Apps for Business. Most of you, I'm sure, know what Google Apps is. If you have a Google account, and you have Google Docs and Google Drive and Gmail and all that. Google Apps for Business is basically their commercial offering of that suite of products. Interestingly, it's not actually the same backend at all. They can't even, Google has trouble migrating from the public version to the business version because it's a completely different stack and it's a different backend, even though they look very similar on the front, which is one of the things we're going to be tackling as a company. We're actually going to be the first company, and we're going to have exclusive tools for migrating from Gmail to Google Apps for Business. And that's going to be part of our platform. But we wanted to offer that to our customers. We wanted to be able to have our hosting customers, our small businesses, say, all right, I've got this domain. I want to have I want to use Gmail for some of my emails, and I want to have Google Docs for my company, and I want to, have all these tools. And so we partnered with Google when we already had a relationship with Get Your Business Online, and we wanted to be able to provide that service to our customers. And one of the advantages of doing it through us rather than through Google directly, because the price is basically the same. Like, we charge the same to our customers as Google charges them directly for a Google Apps for Business account. The benefit of going through us is you can manage the rest of your domain stuff through us. You can have more emails on your domain. So if you have a domain, you can have 3 or 4 emails that you pay for to work through Google Apps for Business, but you can have another 50 that we offer for free that you can use internally that just aren't managed through Google Apps. You can do mailing lists through us. You can do a whole bunch of other services through us as sort of add-on services that you get on top of being able to use Google Apps for Business. So that's what we try to provide our customers, as the benefit of doing it through our platform instead of directly. So our challenges are the fact that, as I talked about earlier, we have multiple platforms. We've got 4 primary platforms that we have to support, and a whole bunch of other business units that may use some of our services at some point. We have multiple languages. We have Perl, and we have Java. We have places where we're doing stuff in PHP. We have parts of the company that would like to do stuff in Ruby. We don't want to be locked into one language. Right? I mean, we like working in Perl. That's our preference at our headquarters here, and most of the company works in Perl. I love Perl. But we want to be able to provide these services internally in a way that's as language agnostic as possible, so that our partners and so that our other business brands that already have legacy code that they're supporting aren't locked out. And we have distributed development teams. We have teams in Texas, both Austin and Houston, up in Burlington, in
Salt Lake,
Provo, up in Utah, in Mumbai, in India. We have a lot of our developers that have been with the company for a while actually live in other offices or in other locations. My team lead works out of his house in Northern California. We've got a contractor working with us that works out of the Bay Area. We've got another member of the team that works out of an old office from one of the companies we bought in Vancouver. So we're all over the place, and the different platforms are managed from different areas. So it's just one of the challenges that we had in implementing this. And so when we thought about what we wanted to do, we wanted to make something that was usable by all platforms. We wanted it to be reusable. We'd seen over and over again where different parts of the company had implemented a connection to some third-party provider that they'd written into their legacy platform, and so somebody said, oh, this is great. Some executive was like, this is fantastic. They're marketing this thing over here, and they're making a shitload of money off of it. Excuse me, a ton of money off of it, over at HostGator. Let's bring it into VDEC. Okay, let's see the code. Oh, look. Oh, basically, we're going to have to rewrite it from scratch. We can use this as a reference, but it's baked into their platform. It assumes it's using their billing system and their customer system and their database, and we wanted to try to avoid that. So we wanted to provide a way for all of our brands to integrate with third-party systems, and we wanted to do it in a way that was reusable and that it was single sign-on from the point of view of the platforms. Whatever we provided, it had to understand our different brands and properties for business intelligence reporting and for any multitude of billing reasons and accounting reasons and a whole bunch of legal reasons that I could care less about. But the platform had to sort of be able to know who was using it for what. And we had to make it a better match for our business and our common usages. And by that I mean Google has an API that it wrote with certain assumptions, and a lot of a lot of the API for Google Apps for Business was hijacks from other places, They've been crowbarring stuff into it, and it really doesn't necessarily, the API that they expose doesn't necessarily match how our business works. So one of the things that we wanted to do was provide an interface internally, an integration internally, that provided an interface to our platforms that better matched how we do business, and so it hit a lot of the warts of Google's API. And then the other thing we had was, as a challenge for this, was a time. When I came back from vacation, I was up in Acadia for 2 weeks camping, and I came back in the middle of July, about the third week of July, and as I was checking my email, I was told, well, before you get too far in your email, we just want to give you a heads up, we've reorganized again. Happens every 6 months or so in my company. For the most part, it doesn't really affect the teams. It's, the executive team thinks about different ways to reorganize how they funnel business down and make decisions, and all that's great, but we're still a bunch of guys sitting in the corner writing software, so, it's a minor adjustment for us, and we just sort of expect a couple of weeks of bumps. This was a little more radical, because the teams had been reorganized, the reset, so we were broken up from 2 teams to 4 teams. So we had some slightly smaller teams. We had some new people that we just brought on board. And they'd actually done something that they talked about for years, which was have some of the people in the Burlington office doing development work that wasn't just for VDEC. And they talked about the Google Apps for Business thing that they wanted to get online. And that was great. And it was exciting brainstorming it. And they told me what the time frame was. The executive team had announced that because they wanted this out in Q3, so they'd announced that it was going to be public for September 15th, which was a little bit less than 2 months away when we had this reorganization. So we got all new teams, all new organization, design a whole new system, and we have basically 3 sprints to do it in, because we sort of figured we've got about 6 weeks or so that we can actually do the design and the frameworking and get all the MVP API endpoints up. And that gives us 1 sprint to make sure that the platform integrations are working. And that's 8 weeks, 6 weeks for us to do our primary development, and from our point of view, for the Rosetta team, 1 sprint to do debugging. But that 8 weeks was not just for us to write a whole new integration platform from scratch, but that was for 3 of our brands to integrate to that brand new platform and be public, have a product that they could market to the public. There was a lot of pressure on this one. So, we had some restraints on what we could do. Or at least that's how we approach this. So what we decided to design, we call the Rosetta Enterprise Service Bridge. And I think Tom actually helped me coin that phrase. I think it was in a discussion with you when I was sort of trying to describe it, and you were like, "Oh, so it's like a service bridge," and I was like, "Yes, that's exactly right." And the idea basically is as we sort of lit up, we've got all of these different integrations we want to do with third parties. And we have a whole bunch of different platforms internally. So the goal was to provide one place that all the platforms could integrate. Because you've done a lot of API integrations. The biggest pain points with integrating with APIs is getting that first freaking endpoint to work, getting the authentication to work, and all the networking taken care of, and the whitelisting IPs that have to be IP, and figuring out how you're supposed to format the data, and which things go in the query, and which things get encoded how, and is it JSON or is it SOAP, or what's the interface to it, and when they get a response from the APIs you're integrating to, are they consistent? Are they always returning JSON, or are they returning different types of things under different circumstances? And what HTTP codes do they use? And usually, once you get your first endpoint or 2 of that integration working, things speed up. Because now you've actually got some kind of framework that's making a call to this remote API, and it's getting a response, and it's doing its authentication, and now you're getting a data structure that you're parsing from, hopefully their relatively consistent response, that you can do stuff with in Perl. So what we wanted to do is get rid of that cost for most of the company. So the idea of the service bridge is we're providing a RESTful API that we're using JSON back and forth. All of our platforms have one authentication token, right? So we have a single way to authenticate. Each platform has its own authentication token that it can authenticate as, and it can tell us what property and what user and all kinds of stuff about who it's authenticating for and what it plans to do. But all of our platforms write one client that understands how to talk to Rosetta, and we deal with all the networking issues of getting all of that stuff working. And they know how Rosetta takes in arguments, and they know how Rosetta returns values. And once they have that client written, they never, ever have to write it again. So every third party that we integrate with, and we've already got Google Apps up online, we've got another one we're launching in a couple of weeks, and we've got 3 more different third-party providers we're planning integrations for over the next few months. So we expect within 6 months we're going to have at least 5 major third-party integrations on this platform. The platforms have already paid the price for integrating with us for Google Apps. So each other thing that they integrate with, they have to do all the work of their UI and their platform and figuring out how they're going to manage those services internally. But they're going to, no matter how we did this, they're going to have to do that. The part of them integrating with another third-party provider is now almost trivial, because now they basically just subclass a couple of files, set up the client, look at our API docs, and figure out what they need to do to call to get information in and out. All of that networking, all of that error handling, all of that client writing, all of that stuff has been done once. They also don't have to have, and this is one of the big things, like with Google Apps, I did a lot of the work on the design of the architecture of Rosetta. Ryan Barr, our team lead, did a lot of the work on setting up the servers and how the servers were going to work and how the systems were going to interoperate. And he reviewed all the code that we did and sort of acted as our primary sounding board to make sure we were making good decisions. But Lisa Walmark, somebody who had just come in from another company a couple of weeks before I got back from vacation, she probably spent 2 or 3 weeks doing research on how to talk to Google. How does Google do authentication? What are their API? I mean, she read all of those docs. So by having a team, having the Rosetta team, we take the pain of not only providing that thing that everybody integrates with once, but all these other brands, all of those other properties and platforms we have, none of their development teams has to spend all of that time reading all of Google's API docs and Komodo SSL's API docs and whoever else, figuring out how those APIs work differently. None of them have to have that cognitive load of learning that one person at this place, one person in this office, one person or 2 people in this office. So we've reduced 4 or 5, 6 people learning the same thing in different locations to 1 or 2 people learning it in one location. So we had a bunch of decisions to make right up front. What server did we want to use? Well, we went with Mojolicious. We decided Catalyst was going to be a little bit too heavy a load for what we needed, because really we wanted a pretty lightweight routing controller. We didn't need a lot of services from it. We weren't serving any web content or anything like that. And we had serious time constraints, and a couple of our people had worked a little bit with Mojolicious in the past. We sort of went back and forth between Mojolicious and Dancer a little bit, but basically we needed something lightweight and we needed something we could get working with fast. We had 6 weeks. We didn't want to spend a lot of time learning an application. What was our code framework we're going to be? Were we going to do OO or functional? How were we going to design the framework of code? What was going to be our coding standards? Right? How are we going to lay this all out? So we decided to go with Moose. We decided we wanted to go OO, and if we were going to go with OO, we decided we did not want to just use vanilla Perl objects. There's some nice things about Moose, and if you've done object-oriented development, having some attributes and having some of the functionality that you get from something like Moose is really handy. But I got to tell you, the #1 freaking win is roles. If you're doing object-oriented development and you're doing something as complex as we were thinking about, where you're going to have multiple different integrations to multiple different third parties, so we knew we were going to have a lot of code reuse. We knew we were going to have a stack of code that talks to Google, and a stack of code that talks to another provider, and a stack of code that talks to another provider. But they were all going to do largely the same things. They'd had to know some specifics about talking to those providers. And roles are just a much, much cleaner way of providing common shared functionality than trying to do inheritance and trying to call libraries. It just makes a lot of your design a ton easier. Well, all right, we didn't actually use Moose, we used Moo, because we didn't really need a lot of Moose's load. Really, and so far, now that we're a few months into this project, I'd never used Moose before this. Never used Moo before this. I'd used Moose. There's only a couple of places where I've been annoyed with the choice of Moo over Moose. It gives us pretty much everything we want with a lighter load. How it does some stuff like method modifiers that it's after is a little bit useless. It's got a couple of things in it that just don't have some of the features in Moose that Moose has that I liked, but nothing that we couldn't work around. Nothing that a little bit of change in thinking about how you design it wouldn't solve. So we've been pretty happy with that design. Which database were we going to use? We really wanted to use Postgres. We lost, mostly because our NetOps group has a MySQL DBA and has a lot of MySQL experience in MySQL servers, and they know how to set up the master server, master slaves and stuff. And so while as a development team we really preferred Postgres, we went with MySQL, but really we decided we didn't care because we used DBIx class. So from the point of view of a developer in our framework, you don't really care what database it's under. You're another level of abstraction above even DBD. Right? We don't write any SQL. We'll have to write some SQL directly eventually when we start doing reporting or some really heavyweight crazy stuff. But because we're a service bridge, we aren't doing a lot of complex functionality that requires a lot of database stores. We're basically, we get a request, we record the request, we do some other request, we get 8, and then we send data back onto the platforms. So we're sort of just a reference data store. So we don't need a lot of data complexity. We don't have a lot of complex queries. It's all pretty straightforward. This was actually one of our most difficult decisions. I'd used RoseDB a lot in the past, and I really, really like RoseDB. I still like RoseDB a little bit better than DBIx class. Nobody on our team had used it before, so we knew there was going to be some load learning how to use use DBIx. But it's sort of the de facto ORM for Perl. And if you're looking up examples of doing stuff in a Mojolicious server using Moo, like almost anything that's going to be talking to the database that are having documentation examples and how-tos and stuff are going to be using DBIx, using DBIx. So we went with the one that we were likely to get more help on and was going to have more industry knowledge and might be more applicable to people we're hiring over time. Mm-hmm. We almost dropped it a couple of times early on because I was the one who was trying to figure out how to interface to it. And like I said, I'm used to RoseDB, which thinks about some things very differently. So it took me a little while to make the mental shift, but now it actually works pretty well and pretty smoothly. So what else did we want to make decisions on as far as tooling right off the bat? Well, we decided we wanted to use method signatures. Eventually, we'd like to use the built-in signatures in Perl as a 520, but it's not quite mature yet. Also, we really like the method piece. And I don't know if the Perl's internal signatures is going to use that, so I'm really hoping time next year we'll refactor the guts of method signatures to use Perl's internal signatures and just add method and func as little wrappers, and it'll be pretty lightweight. We also decided to use JSON schema. So this was a sort of throw some things at the wall. And this is one of the things that we talked about that we decided was probably worth giving a try, but we weren't certain about when we started out. We hadn't used it, but a couple of people on the team had read the documentation and played with it a little bit. And it's an interesting way to do data validation. We've refactored how we do this a couple of times, and I can show all the code behind this at the end of the presentation. But it's actually turned out to be a pretty good win, especially once we figured out how we wanted to lay out the code so that schema definition. So basically, you have a schema which defines arguments that you want to validate, right? Originally, it's not a Perl-specific thing. The original idea is compare this schema definition against a JSON block, and it tells you whether or not the stuff in that JSON matches your schema. So you can have required args, whether it's an int or it's an enum, what values are allowed, and all that kind of stuff. But one of the things we figured out was that you don't actually need to compare it to JSON, because we originally had a bunch of JSON files that we would load up. You can actually have Perl data structures that describe your schema, because that's what it converts the JSON to. So you can skip the whole JSON step, define Perl data structures that you then compare to a Perl data structure that's being handed in, and it does the validation, which is really cool, because then you can have a bunch of functions that return different data structures, and you can reuse parts of the data structures all over the place. And so that made it really easy for us to say, for Google Apps, we have 5 or 6 endpoints and a bunch of outgoing client API calls that all need the same set of data. So we can define it once and then just reuse it in a whole bunch of places, maybe twiddle whether it's required. So it's turned out to be really handy. And in a large code stack with a lot of different API calls, it allows you to do a lot of code reuse. So we need to manage multiple services. We wanted to reshare as much code as possible. We wanted the routing controls to be simple. And it was one of the things Lisa came in with right off the bat, having done a little bit of stuff with Mojo before, where she had an idea of how to sort of do automatic routing by convention. So you didn't have to write a route per every endpoint that you wanted to do. We've iterated on that a couple of times, and I have a design I really, really like. We wanted automated input validations. We didn't want to have to write, blocks of code at the beginning of each endpoint or client API call, checking, are my inputs valid? We wanted that to sort of just be under the hood. A lot of our design of this whole framework, the whole Rosetta framework, the idea was, once we got it working, we wanted to be able to stand up a whole new endpoint by writing 6 or 7 files that are subclasses of a config file, a couple of subclasses, a schema file, and basically be able to start writing endpoints within a day for a new provider. And we wanted all the code to be reusable in the sense that once you learn how to write code inside of Rosetta, you know exactly what you're getting in. And just like for the platforms, they're integrating a one client to Rosetta and they're getting to reuse that for multiple integrations, we wanted to be able to have the cognitive load as minimal as possible for internal development. So the main differences from one project to another, besides the database schema you're throwing some data in and out of, is how you're talking to that third-party API. So we've got some complex code for how we set up the client that talks to a new provider, and how add how we add hooks to do post-processing on the response and stuff like that. But you have one person who learns that third-party API and implements those changes to the client API subclass stuff, and everything else, you're copying a template into place, you're defining an endpoint path and a couple of things, and you're doing, we're literally now, we can set up a new endpoint where a platform calls one of our API endpoints, which then in turn makes a client that calls out to a third-party integration point that comes back. You're now basically editing 2 files. You might have to create them if you're the first person making that API call out or with that endpoint path. You're creating them from templates, and you're writing 10 or 15 lines of code for the pass-through parts. I mean, we can literally, once we get going on a new provider and the client stuff is working, we can churn out a couple of endpoints a day, right? And it's just automatic, and the framework is just the same for everything you're going to be doing. But for this first project, that was what we wanted to achieve. We didn't know if we were going to be able to do it yet. We estimated we had about 10 internal endpoints talking to about 14 Google endpoints. So that's about 10 APIs on our side, endpoints on our side, talking to about 14 going out to Google. 14 different calls.
Define your endpoint API. What
all right. So we're a bridge, right? So we're in the middle. So an endpoint for us, an API endpoint, is what the platforms talk to. And that's our incoming request.
But what encompasses one endpoint? A set of APIs, one subroutine
call.
Different
so an endpoint.
A lot of ways of doing that.
An endpoint for us is a URI path, and whether it's get, post, delete, put, etc.
It's
right?
a verb.
It's right. it's the noun and the verb. So for us, the endpoint is the combination. The automatic routing we do is actually the path that you send in turns into a class name.
That's easy. I don't know why everyone thinks that's so hard. It's really a fancy hash. in some ways.
Yes, and we can talk about it. Yes, no, it wasn't that difficult. Making sure that we could do it within Mojo's routes and not have routes get confused and stuff like that was took a little bit of testing. But yes, basically your path becomes a class name, and inside of that class we have API underscore put, API underscore get, API underscore delete, and so each of those methods inside of that class for the different HTTP request method is our endpoint, right? So that's what we consider an endpoint internally for what we develop for the platforms to talk to. Our client API methods, so we sort of talk about endpoints and methods so we can get a little less confused. The endpoint is what we provide to our platforms. The method is what we call against the third-party API that we're integrating with. So in here where it says Google endpoints, it should say Google API methods. But and we had 6 weeks to do it. So we want to get this whole framework up and integrate with all the things with Google, and we had 6 weeks and 3 people, functionally. The upside, we were an entire greenfield project. We had no legacy code to support. We got to stand up brand new VMs. We got to pick all of our own stuff. We're working on Perl 520. We're using Pinto. We're using Perl Brew. You know, we got to do all of this stuff from scratch with no need to support anything else. So it made it a little easier for us because we didn't have to worry about breaking stuff. We didn't have to worry about trying to learn other stuff. We just wrote. I could just sit down and say, okay, I'm going to work on this part of the framework today, and I could just sit down and code without interruption for hours and hours and hours, and just my test was the only thing that had to work. So this is what we settled on for a system design. We have a load balancer that sits in front of VMs. The load balancer talks to an Nginx reverse proxy. Nginx routes internally to server instances. Each of these server instances is a Mojo server on that machine. So how we do this is when the request gets to Nginx, it looks at a couple of headers. Well, primarily it looks at the accepts header, which tells it what version and what protocol somebody's requesting, of our software somebody's requesting. And it also looks at a provider header, which is a custom header. So the provider is something like GAPS, SSL, Office 365, whatever we're providing as a third-party integration. So basically, when the platform calls to us, they say, I want to talk to version 1 of the Rosetta software, and I want to use the GAPS provider services. I want to talk to beta 1. So we provide a beta server, a staging server, and a production server. Nice. So they basically, in the accepts header, say what version of our software and whether it's beta or staging or whatever they want to talk to, and they tell us what provider service they want. Nginx uses that internally to map to an internal IP address and port. So each of these server instances is running on a different port on the internal IP. Those server instances don't talk to the outside world. Nginx is the only thing that talks to them. And so it routes to these different server instances. We decided to do it that way because if we blow up GAPS one day, one of these servers becomes corrupt because we checked in some bad code or Google went down or who knows what happened, right? The Google Apps database got corrupted. All of our other services keep running.
So are you running one server under one VM?
No. Okay. One VM runs one Nginx reverse proxy with multiple server instances. Each of the server instances.
It says VMs in that big blue box.
Because we can
you can clone that.
We can clone that as many times as we need. Currently, we run 2 for redundancy. If we ever start having load issues, we'll just start adding more ones. If we ever want to get lower latency, we can stick copies of these VMs in other continents.
So each of those is a complete web server running Mojo, or the server instance.
Each server instance is a complete website. It's a Mojo instance running on Hypnocode.
Different ports.
Yep, each one's a different port running on Hypnocode. And they talk to our MySQL master, which in turn talks to the slave. So here's our request cycle. The request comes into Nginx, which dispatches it to a server instance. Mojo's route control then figures out what route it wants to do. If authentication is required, or if they're requesting authentication only to get a session token, we handle that. We return the session to the route control. It then does any dispatch validation, which is basically, if it's not done at this point with auth, if that wasn't all that was requested, it now looks at the API path, and it basically says, does this map to a class name, and can that class, literally class can API method, HTTP request method. So, is this something I can actually handle? And if it isn't, there's an error, and that's what all these are. These are errors. If it can handle it, then basically it calls endpoint on the server, providing the class and the arguments that came in. Mojo also handles basically taking any, it's if it's form encoded. We're very flexible with our platforms. They can hand in as in a post form and have the contents in the form. They can hand it in as JSON content. They can do query parameters. There's certain values we might take from the URL. If we have like an ID in the URL, a placeholder for an ID in the URL, the Mojo route is baking all of that into one set of requests, one Perl data structure that it's going to hand into the API endpoint. The API endpoint, when it's instantiated, validates the input. And we did this both for the outgoing method requests and for which is here, and the API endpoints that we provide. The validation happens during instantiation, so the person writing the code for handling requests and stuff, they don't have to think about validation, because if the inputs weren't valid, or at least as valid as our JSON schema could possibly restrict it to, then it never actually got to your code, because during instantiation it said, nope, or this is invalid, and it returns an error during instantiation. So it never actually gets into the actual handler code if the inputs are invalid.
So you don't have to remember to code it.
You don't have to remember to code it.
Nice.
It's
declarative,
yeah.
Effectively.
Most of what we do is declarative.
Nice.
So somebody has to go into the schema def and write the validation you want, but as long as your naming convention matches the class dispatch convention, whatever you have there as a data structure returned from that automatically gets validated. You just define the data you want.
This is going to be one logical thread for each Mojo server. I mean, it's not multi-thread. Okay.
Yes, Mojo's the Hypnotoad is it's not multi-threaded. No.
Okay.
It starts up multiple children and can dispatch to any number of children, just like most modern web servers.
Yeah, no, I'm just trying to ask you. So basically, I'm talking about not talking Nginx. The instances of each Mojo, okay?
Yep.
They're taking one request from the socket, the HTTP request.
Yep.
They have to run through all this in a linear, single logical thread. Then they return a result. It's blocking. Right?
Only for its own request, yes.
Right.
It doesn't block anybody else's request.
No, I know that because they're in different processes.
Right. There's no advantage to. I don't see any advantage to threading.
No, I'm not looking at thread. I'm just asking. I was not questioning in terms of what you're doing. I want to make sure that basically each Mojo instance is a single thread that goes through, returns, gets another request.
Yes, understanding that it forks on me.
It's not. Yeah, forking meant earlier. I'm talking about that later on. Okay.
All right. So assuming the input validates, it then executes the endpoint. Inside of the endpoint, it does whatever code you need to do. Some of our endpoints don't actually call out to a third-party provider. Maybe it's just somebody's getting information we already have in the database. Right? So we're returning that information. But most of them are going to have to call out to a third party that we're integrated to. Sometimes they'll call out multiple times, which is why this sort of looks like a little loop, because one endpoint on our end, like for instance, for the Google Apps, when a platform calls account post, so they're creating a new Google Apps for Business account, there's actually 3 or 4 different calls we're making out to Google that are part of that endpoint.
And you're simplifying that process for your internal platforms by doing 3 calls for 1.
Exactly. Because there was no instance for creating a new Google Apps account. There was none of our platforms that were ever going to need a smaller number of those operations. So we might as well bundle them all up for the platform. If the platforms need to do some of those things that we do in there separately, we provide a different endpoint to do them one at a time. But our job for Rosetta is to make it as simple for them to do what they do for their business as possible.
Just common stuff to be done simply.
Yeah. So again, we instate the client API method. It validates its own input. It does the call out to Google. It gets a response.
Wait, why is validation done again there?
Because here we're validating what the platform gave us.
Yeah.
Here,
What Google tells them.
no, here we're validating what we're about to send to Google. Because if we screw up between here and here, I don't want to waste the time calling out to Google.
But wouldn't if you validate the input of the purple one, whatever?
What we provide to the platforms, because remember, we're providing one API endpoint that does a whole bunch of different things, right? So we do different validation here. There might be different arguments here. There might be things in here that are only relevant to Rosetta and not to Google. Our naming conventions are different, right? So what we validate here that's going to Google can be very different from what it is here.
But you're doing your own translation, though.
Yes.
It's
So
somewhat,
why? Okay.
it's somewhat belt and suspenders.
And it's Phil's belt and suspenders a bit.
Sure.
Okay.
Do you ever aggregate content from multiple sources?
Yes.
So that would be another reason why you'd want validation in two different places.
Don't send a Yahoo session ID
Well-
to Google.
No, I was saying that if your first validation was that point.
No, because we want the platforms to provide us as little information as possible.
Okay,
So-
so you want to isolate that validation at the platform level.
Right. Now,
Okay. That may also mean your platform.
now going back to what I said about JSON schema, if there is repetition between what we're validating here and what we're validating here, we're actually only defining it once. We're just having this reuse parts of what we defined up there.
Okay.
Um,
So a common data structure, we validated the same code.
exactly. But if the data structure is different, then we can have different pieces at both of those levels.
Right. Okay.
When the endpoint returns, we complete the request. And there's lots of places. You can see here, we could bail out of this code path on error for any number of reasons. Whenever we bail out, this got a little bit funky when I resized it for the slide. This is a bigger doc. Wherever we might bail out, we always complete the request, right, before we send it back. And we have a serializer, right? So each of our platforms, we could define some. If they really wanted to, they could say we really need these things renamed in this way, or we don't want JSON, we want XML, or whatever. We're trying to support as little difference as possible because we have to tell the business. They have to explain to the business why they should pay us internally to do that for them.
It's all Perl down here.
Yeah, but just in case, we basically have a little serializer. So what this calls is basically says I've got this response object that that has been composed and returned to me. It might have errors in it. It might have all kinds of stuff in it. It's got the HTTP status it should set. We instantiate a serializer. We serialize that, and we call Mojo to compose that response out to the user. And that's basically the whole request step. I'm going to have to, hold on. Let's just share the entire screen. So that's basically how we designed it.
Can you blow that up?
Well, yes, I can.
Well, the joys of Hangout, even if you blow it up, we may not be able to at this end.
That's better.
All right, so that's the design, right? That's the high-level view of what we're trying to accomplish and why, and how we handle the requests. This is some of the guts. So this is our Mojo base class. So every server instance is going to subclass this file. Mojo does. This is the Mojo controller. This is some information that's being handed in. We read some configuration stuff. This stuff happens for every server instance. So whether it's SSL or Google Apps for Business or whoever else we're integrating with, whatever service we're integrating with, this stuff happens all the same. We set up our logging for the Mojo instance. We have pod renderer, which we're not using, unfortunately, but we would love to. I don't know why that jumped. One of our long-term goals. And then here we do we start setting up some routes. This part is, we have an info endpoint. This is the only endpoint that doesn't require authentication. So if a call comes into info, we handle it with a different controller inside of Mojo that knows it doesn't have to do sessions, it doesn't have to do authentication and stuff. This is basically, we provide two endpoints there at the moment. Ping, which just says I'm alive and you're talking to the SSL service, or I'm alive and you're talking to the Google service. And it has one for error codes, which just returns all of our configured error codes that we could possibly return. They were there largely, they were some of the first ones we implemented just to make sure that we had routing working and could talk to ourselves. We have a route for auth, and this is basically where when the platform first wants to do a whole bunch of stuff, it calls auth, and we have a shared secret in the way that we do an auth sig. Which has time in it and all that stuff, and so we compare our we create from the shared secret a sig, and we compare it to their auth sig and validate that it's the platform that it's claiming to be, and return a session. This can actually be baked into your first request, so the client doesn't have to do this separately. It can do this as part of its first endpoint call, and then get the session, and then use the session after that.
This is a greater app-to-app session.
Yep. Yep. So this is one of the platforms contacting, authenticating to us. Once they have a session, the session is good until it's been inactive for 15 minutes, and they can do as many calls as they want. Now, generally, this session is authenticated on behalf of a user. So the platforms only need to know how to authenticate one way, right? The authentication process is the same, but when they authenticate, they say, I'm going to be doing stuff for this user.
Okay.
That's the user ID. And once that session is authenticated, that session can only do stuff for that user. So if it creates a Google for Apps for Business account, if it gets an SSL certificate, whatever it does, we record it as being for that user. And so that user's session can't be hijacked to do other things on other users.
Great answer.
At what layer is that enforced? So for example,
being from hijacked.
Oh, so if somebody...
Authentication credentials are something that are negotiated between the client and the server. The
Yep.
user isn't actually a party to that.
Correct.
But the user ID is information that's passed with it.
Correct.
So what's to stop the client from sending the incorrect user ID and getting requests from different sources? Is there any enforcement of that?
No.
Not a session cookie or something?
Well, not in the sense that, so what he's saying, like if somebody actually got control of the client and could generate a new authentication request for a different user, there's really no way we can detect that. But they would have to have...
So generally, you're dependent on the clients to be well behaved then?
Within a certain amount, yeah. We don't talk. Rosetta doesn't talk to external IPs. We whitelist IPs for our other platforms. So if somebody hacks one of our other platforms, then that platform's customers become vulnerable. Mm-hmm. Platform can't authenticate.
But that was already the case anyway.
But that was already the case anyway, right?
Yeah, even more mundane scenario, just programmer error, you could have that situation occurring.
Yes. Yeah. But there's not a whole lot because we can't know of all of our platform's customers in advance because a lot of times they're contacting us to provision a service for a customer that's in the process of registering. So there's no way for us to know in advance that the customer even exists. So we can't have a preloaded list of customers that we can validate.
That wouldn't scale.
Yeah. So we have to take the platform's word on the customer they're authenticating for.
But you said it. But the platforms will set up a session per their customer session as opposed to one per client business entity or for the whole platform.
Correct. And that
simplifies
that real user somewhere out there, whether it's a real user that's representing a business, not ours, whatever, but that real user out there, once the platform authenticates that user to do stuff, that's the only...
You're only going to do things.
Right. And once a user is created on one platform, another user, so inside of Rosetta, we associate each user with the platform under which it was created. And so another platform may have a user of the same name, but it's a different entity in the database, and so they can't, platform customers can't overlap and accidentally use each other's stuff, right?
Yeah, it's good.
And then here we do a bunch of dynamic routing, and I'll show that in a second. I'll go down to the docs. We set up those paths. We do some Rosetta logs. Some Rosetta args. This is just a bunch of stuff we get out of the config and the routing pattern. This is a bunch of stuff that we want to make sure that the router, that the controller paths have access to in the Mojo configs, which is the defaults. So you do Mojo defaults, and it becomes available in Mojo stash and controller stash in a Mojo instance. This is the startup. So when you start the server, this is run. This isn't run per request. And then the other thing we do here, just in case everything blows up horribly and we don't catch the error in our application and Mojo catches it, this just makes sure that it still gets sent to JSON, because that's the only return format we support. So it's still, this is Mojo's exception. So if Mojo catches the exception we missed somehow, the Mojo's exception is returned in the same JSON format as everything else, so that somebody's client doesn't barf because all of a sudden they got an HTML page instead of
Nice, nice.
So that's just a little fallback.
And JSON makes that easy. Nice.
Mojo
makes that nice.
Mojo makes that nice, yeah. If we ever have to support multiple response formats like XML as well as JSON, then we'll have to have a little thing there that picks one based on the accept header. But
obviously doable if necessary.
Right. This is not the one I wanted to do next. All right, so this is the router. So when you set up the Mojo instance, basically you have to have a subclass of two things. You have to have a subclass of the Mojo class, which we just showed, which is what's run at startup. And we have to have one for the router, which is what actually handles different routes. So just really quickly, we have main. This handles most requests. We get our own API server. So this API server is actually sort of Rosetta's primary controller. And it actually sort of stands side by side with the Mojo controller. We pass the Mojo controller into our API server. There may be, when we learn Mojo better, there may be a better way to have a subclass of something in Mojo that extends Mojo with the functionality we needed, but we knew how to write the server stuff that we wanted as far as how to call endpoints and all that stuff, so we wrote it separately, and Mojo they just sort of share responsibility. We get the params. That's like I said, it's just compiling params for a bunch of different places, potential places. And then this is a pattern you'll see all over the place in our platform. Because we have a error handling role, when errors occur, we stack them up inside of the object. And so all over the place you see return if has errors. This is the only place you see complete request if has errors, because when you come out of the requests, when you come out of the stack, you end up back here, because this is what's actually doing. This is what's actually doing the handling. So this basically tells Mojo to return the response. We're all done. But you'll see all over the place. If self has return if self has errors, return if self has errors. That's how we do our error checking. And then our serializer knows how to properly format those back to the platforms in a consistent manner. So then we do the authentication. So this is the main one. So here we check authentication. Authentication could be an auth-sig, which means it's initial authentication. They want a session returned or created, or it could be a call-sig, because we not only do we have a way to sign to make authentication, but you still have to make a call-sig for every API call. So the client, there's a session token that goes back and forth that anybody can see, but there's a secret way that we create a signature on the call that we compare. So each method call from the platform has a signature on the call, that we make a signature internally based on we know how that signature is done, and we compare the results. And if the call sigs don't match, then we refuse the call because we're a little paranoid.
Good.
And again, so unless it's authenticated, we complete the request. If anything else happened that we didn't catch, this is like a little bit of a ghost line, I think. Then we build up the class, right? Based on, like I said, it's EIG service class. So this is Google Apps or SSL or whatever, API, and then whatever we pulled from the path. That becomes a class. We then call endpoint on that class with the HTTP request method, right? API method, and whatever params that Mojo parsed out of the request. We do that in an eval, just in case. If there was, we add an error, and then we complete the request. This is the info endpoint that we talked about, which just doesn't, it does sort of the same dispatch, but we know it's going to a particular class, and it doesn't do authentication, and this just does auth. That's the auth endpoint. And everything else is just sort of helpers for compiling the params and stuff. Let me show you real quick. Oh, actually, I want to go down here. So here is our Google Apps. This is the Mojo subclass for Google Apps. You'll notice we use Mojo's subclassing syntax for that. So this isn't move for this piece. We stuck with the Mojo's way of doing things. And here there's a routing pattern. And so each service instance declares a routing pattern, and this determines the default route handling for endpoints. So for Google Apps endpoints, it's service, resource ID, section ID. You'll notice like these are namespaces for the class that we'll compose, and these are variables. So when we auto-generate routes in the base class, based on this routing pattern, the ones that are type NS, those parts of the path will be made into part of the class that we're gonna run the endpoint from, and the ones that are type V, we stick into the params. So if you call /foo/bar/15, we're going to call a class foo::bar, and it's going to have in the request bars that we hand in, it's going to have resource ID equals 15, parsed out of the path. In any occasion where a platform sends in the request parameters, like the form parameters or in JSON, if they send in resource ID equals 15, but there's a 17 in the path, the URI path always takes precedence. And then
No lying allowed.
Yeah. And then it does the startup, gets its router. Now, most of the routes for Google Apps are defined by that default pattern. But we had one that didn't fit. So in the subclass, we have a API path here, an endpoint path, that doesn't match the default pattern. So you can do that. We can have as many ones as we need to that don't match the default pattern. You just define them here specifically. So we have, at this point, I think we have 19 endpoints that match the default pattern and one that doesn't, or 18 that match and one that doesn't. You'll also notice that this goes to route and main. If we really wanted to have something other than main, like we have main, auth, and info, if we wanted to have in our Google Apps subclass a specialer, you could also define that here. So again, this is run at startup. So it does this stuff here. It calls super startup. The next thing we do is we have this Google Apps stash thing for those Rosetta args that you saw, and we build DB caches. This is actually, I'm not going to bother showing you the code, but basically, as in a lot of applications, there are some tables in the database that don't change. right? They usually only change as part of a code release because you're adding a new reseller or you're adding a new, whatever. So those tables that don't change except as part of code releases, they're not dynamic, they're not part of the flow of API requests and stuff, error codes, all kinds of things. Those tables we actually read out of the database at server start and put in memcached. So when somebody wants to read that information from the database, it actually just comes from the memcached instance on the local server. So it skips the database entirely for all the basically static information. It's still in the database. That's where we change it. That's where we maintain it. Because we have to do joins and stuff. If we didn't have to do joins, it would just be config file. But because it's stuff that we want to be able to do joins and want to be relevant to foreign data integrity, it's in the database, but we want it to be basically like a config file.
And take your read-only copy from the database to make sure they're the same.
Yep. And then here's the router subclass. And this is pretty much all we have to do for the router for most of our things. We just define the service class that it's running under. That's it.
That's it. Nice.
Because that determines, that service class Google Apps determines the namespace for everything it calls. And because we follow the same convention in every provider that we support, once we know the service class of the provider, we know the base class name. Because everything's subclassing and using the same roles, everything behaves the same. So all we need here is that one service class, and that tells us the subclass that we need to, the namespace of the subclasses we're loading up. And the behavior is consistent because all of these things are using the same roles. So there's a certain consistency in behavior. The only thing that's different is the stuff that's specific to that provider. And we do that with different names, and we do that with callback hooks and stuff like that.
So this is magic name dispatch.
Yes. All right, so that was the router. This is the server. This is what is API in the router. For the most part, all this doing is setting up a bunch of input args, request args, retries, response, payload. The API server for us is basically, its main thing is it knows how to get a bunch of stuff from, oops, I'm looking at the wrong thing. Hold on. That's why I'm confused. Here's the API server. Controller version, response type, character set. So this basically determines whether or not somebody's told us they're UTF-8 or not, they want UTF-8 encoding or not. The call sig, the result, the session. The main thing the server does is it knows how to build a whole bunch of attributes from the headers. So based on what headers, so we've got a logging role, and we've got a whole bunch of different roles. And so like the logging role, in the config, we set the log level, debug, trace, info, warn, whatever the log level we want is. But we actually have a log level header that the platform can provide. So when I'm testing something, maybe I'm calling it against production, which is only at log level warn, but I can send in an XEIG log level header of 3, and it turns it onto trace just from my request.
Nice.
And so there's a number of things we do with headers in that way. The main thing that this does, though, is it calls endpoint, which just does that class validation and knows how to compose the information. A lot of what this does during the endpoint is right here. So actually, there's one interesting thing I'll show you. MOFs. Because all of these classes use roles for things like log level, how they access DBs, all kinds of stuff, but particularly for log level and transaction reporting. When we create the server instance at the initial router, so the server is created at the router, and it reads stuff out of the headers, and it sets its log level. Tracking ID is another thing that we recommend our platforms with every request send a tracking ID that they use in their logs, because we set that as the tracking ID in our logs. And so if they say, here's my logs for this tracking ID, this request went wrong, I can take that tracking ID and I can grep our logs for it, and I can get every log entry relevant to that. How we make sure that propagates all the way down the chain is we have an object factory role which just provides this MOFs as make object from source, or self, or whatever we can remember it is, which is basically we want to create a new class, a new object off this class. So it's just class new with these args. But there's a whole bunch of stuff that we want to make sure gets passed through: the log level, the tracking ID, the log category, the provider. So whether it's gaps or et cetera, it's a whole bunch of attributes that are shared amongst pretty much every mu-based object in our stack. And so all this basically does is, if it's defined in myself, provide it as an argument to the class we're creating.
Oh, so the role type arguments get inherited when you create a new thing with self-MOFs.
Yep.
Okay.
And so all of our classes have the self-MOFs. So basically, whenever you want to create a new object in our stack, you do self-MOFs class arguments.
And MOFs may set errors in self instead of in the created endpoint here.
Correct. So
So MOFs has side effects to self potentially.
yes, the only like I can open up the object factory role, but basically it's eval use class, eval class new, and so if either of those evals blow up, it sets an error on self because it doesn't have anything else to set it on. And then if new doesn't blow up, but it also doesn't return a reference, if we don't get an object, it also sets an error on self. And then so we do if self has errors. So we weren't able to create the class we wanted to dispatch to. We set a 404 response and we return.
I have a silly question.
Yep.
Since HTTP is really text, wouldn't that 404 be better as a string? Minor thing.
Actually, now one of the changes in a recent refactor is we've actually now have an HTTP status role. So now it would actually be self arrow HTTP underscore whatever 404, whatever the mnemonic for 404 is. So we're slowly, you might see that in a couple of other places. We're slowly replacing the numbers with the string mnemonics.
Even so, it should be a string 404 since it never uses a number anywhere.
No, it returns a number.
Perl would do the right thing.
Huh?
What?
It's Perl.
I know that, but just saying.
Calm down, Ray.
But it actually sets a number. That's the response code it sends. That's in the header is 404.
Right, but in the header it's a string.
No, in the header it's a 404. Well, in the header it's
404, and then you can put a text string out.
yes. But you know what? We don't actually deal with that. We tell Mojo we want a 404
I
response.
understand that, right. I understand
We just pass it on to Mojo. So anyway, so then we do that can, right? So if the class, the endpoint can do the method. If it can't, rather we throw an error. If it can, we call it. And then this is the last sort of funky piece, which is where basically we take from the endpoint, if it has errors or status or results set explicitly in the endpoint. So that's why we use the has. If you're familiar with Moose, those are predicates, which is nice because it doesn't check to see whether it's defined or whether it's true or not. It checks to see if it was ever explicitly set. So when I say has errors, I'm not accidentally invoking the default setting, right? Because the way attributes usually work is if you access them, if they have a default, then you'll get back the default value. If I do self has errors instead, it doesn't accidentally cause that default to be evaluated, and it tells me whether or not the attribute was ever explicitly set.
No auto viv on the has.
Exactly. And so this allows us to say if the endpoint ever set this status, set this attribute, inherit it up to the API, because then when we complete request.
And you check this in sequence, errors, status, and result.
Well, go back to the code for a second. Okay, so the predicate is different itself than the key, because the last thing you're doing is you're setting the self's key.
Right, so these are basically attribute names, right?
Right.
And so this is a predicate on that attribute name.
Okay, but the last thing you're doing there is you're getting the value of the key, the value errors.
Right. If it was explicitly set in the thing we called,
And you won't get any default.
set it myself. Exactly. We don't. This way, we never accidentally propagate defaults. And that's basically just to make this a little easier when we do the complete request. Here, like I talked about log level, we encourage everybody on the team to put in logging liberally, because if it's too noisy, we just make it from debug to info to debug or debug to trace. If I call it with log level trace, I expect to be groveling through a whole lot of logs, but it's because I need to. Oh, and we have one other thing. Like this is just some is log level debug. We only do this like log if log level when we're doing dumps that might be large, because errors is actually it's actually an array of error objects. So we don't want to grovel through, because if you call this without if, it will grovel through and do the dump, and then it will go to see if it's going to log, and if it's not debug level, it's not going to log, but it's already gone through the work of doing the dump. So the little if at the end there is basically we only put that in when we're doing a dump on something that might be expensive to grovel through, just to avoid the execution. Right. So if self had errors, we set it to 500 unless it was set to something else. Right? If self has session, we do some other stuff on the serial. We get a brand-specific serializer. There's a trace. We create the serializer, and on the Mojo controller, we render exception if there's an eval issue there, because we can't serialize it in a custom way. And here we go through my whitelisted keys. So these are the things we want to consider in serialization. So our version, session, result, errors, tracking ID, and provider all can potentially get serialized.
And unless the key is serialized, it doesn't get exported out.
Correct.
Nice.
And then that calls the serializer.
So your internal data structures can pass around all the way until here, and they don't escape.
Yep.
My former security self appreciates that.
You're welcome. All right, let's see if there's anything else interesting here. No, that extends Rosetta. You don't really want to see that. You want to see this. So this is our most common base class. Not everything inherits from here, but most things do by chain. And that's the role that pretty much everything needs. Those are the roles that pretty much everything needs. Some things don't, and so they may have their own different class, and they may only use some roles or different roles. But this is sort of the default set, right? So everything knows how to log. It knows how to read configs. It knows how to handle errors. It knows how to access the DB. It knows how to access memcache. It knows how to record transactions, and it knows how to
use the MOFs.
Use the MOFs. Transaction handling is one thing that we're probably going to remove from here and push down in the stack a little bit, because it's really only needed in 2 specific branches, so we're just going to load that role at the base classes for those 2 branches. So it'll just be defined in 2 different places. But that pretty much everything needs, other than transaction handling, pretty much everything needs to know how to do these things. Let me show you real quick. So we have a DB access module. So we're using DBIc, right? But if you've ever used DBIc, when you want to get a result set, or there's a whole you have to know the name of the schema you want to load, and it's like there's this whole little stack of code that you write that basically says, I want to connect to this database, and then I want to get this schema, and I want to compose this result set, and I want to do this, that, and the other thing. And in a large application stack that could potentially basically provide, because the API server object class does some things differently, and the config and the config reader does some things differently, basically based on whether or not your operational environment is development or beta or staging. So it could connect to a different database. It could read in different configs.
Certainly hope so.
Right. So our config role, basically we have a defined hierarchy of it's going to look for files in this location, and then this location, and then this location. It's going to merge everything it finds. We do write-wise merge, so whatever you read in later in the stack overwrites anything it already read in, so there's a default. So if it sees, when it's reading in a config file, if it sees a beta section in the config file, then it looks at its op environment, and it basically says, if there's anything in the file that I just read in that matches my op environment, overwrite the defaults with that, which is a little bit complex. But it allows us to have really, really tight control, really, really granular control over the configuration spectrum that any instance runs under, based on its operational environment. And the developer files, the developer configurations are always loaded last, So when I'm running in my own directory, I can always throw whatever I want in my developer config, and it's going to overwrite whatever else it read in from anywhere. So DBRS is a method that comes from the DB access. And so basically, this is saying I want to access our Rosetta database. Inside of DB access, it looks in config to figure out what the username and host and port and password. So it looks in the config for the Rosetta database for its operational environment, gets that connection information, connects to the database, gets the brand result set, and returns it. And so, here I can do self DBRS. So this goes, okay, go get me all of the brands and iterate over them. Right? So this basically just gets rid of all that DBIC boilerplate. Nice. And so all over our code, this is how we do that. In most of our functional code, like in API endpoints and stuff, usually you'll see something like that with a find or a update or whatever, and then return if self has errors. There are a few places where we have to wrap that in eval because DBIC insists on dying if there's any issues and doesn't want you to change its error handler, doesn't want you to fuck with the DBD underneath. This caused me some frustration because I don't want to have to rep DBIC and eval all over the place. I want DBIC to set an error on self so that I can do DBIC thing, return if self has errors, because that's our idiom. That's what we do everywhere. I finally got a useful response on the DBIC mailing list a couple of weeks ago with where to put in the right, where to put a file in the right place in the class hierarchy in DBIC that will automatically get read, that will allow me to have it do the self add error and add that handling without having to do a wrapper or without having to set unsafe on the DB connections, which I really did not want to do. Yeah. I'm like, can you please give me a way to have DBIC fit into our application stack without telling DBIC to just potentially blow up all over the place because I've told it it's unsafe, or I didn't want to go there.
Yeah. Nice. And that was already in there. You just needed to find where.
Yeah, it just wasn't documented. Yeah, it's not going to be trivial. I haven't gone back and followed those instructions yet, so I don't know how well it'll work. But at least I have something that somebody from the DBIC mailing list, one of the DBIC maintainers, believes will do what I need.
If it works, you should probably submit a patch to add it to the docs.
Yeah. All right. So let's see. What else is interesting? That's the end. This is the endpoint role, which is basically just how things that are going to be endpoints know how to handle the default request method, what its name is, what the result is, know how to get the session. One of the things we do is...
And the predicate one there implies the existence of the has.
Right, exactly. Yeah, so predicate result, yeah. So that's how, if you say predicate one in your has definition, that gives you the has attribute.
Result,
yep.
In addition to the result.
Yep. And instead of having one, I could specify a name there if I wanted to name it something else, but I don't see why you would ever want to do that.
But the way you're doing it, you definitely want it auto-named.
Yes. And you pretty much always want it to be underscore has underscore attribute name. So one of the nicest things about roles, besides the fact that it gives you a safer way to sort of mix in functionality and attributes into a class than inheritance, and there's plenty of great articles out there by Ovid and Chromatic and stuff about why, if you're going to do inheritance, roles is a superior way to do it. But one of the things I really love about Moo and Moose, and this is true whether it's a role or a class, is this whole builder concept. Because this gives you a really, really easy way to have default behavior that you can, so we've got this stack of service providers, or provider services. So we've got this big stack of provider services. So we integrate with Google Apps and SSL providers and all kinds of other third-party things we're going to interact with over time. And each of those things are going to need to be able to have its own default for this attribute. Well, rather than redefine this attribute all over the place, we can define it in the base class or in the base role. And then in the subclass, we have a method build name or a method build client. And that just overrides this behavior, right? So the subclass's version of this builder is going to get called to create that attribute instead of this one. So here, in this case, the build client, right? So the client attribute.
That fatal there basically means that's a pure virtual method that must be overridden.
Exactly. Exactly. So the client is the client API. So that is the object that we're going to talk to Google through, right? The client knows, the Google Apps client knows how to talk to Google. The Komodo SSL client knows how to talk to Komodo, right? So the end.
When you say SSL, you mean certificate provider?
Yeah, Komodo's a certificate provider. So each individual provider's client needs to know how to talk to that provider, but every endpoint needs to have a client. It needs to have a client that it talks to its provider's thing with. And so, yeah, this is the virtual builder that basically says if you don't override this in your subclass to give you the specific one, blow up because you've done something wrong. Like you can't not have that and function in our stack.
Should never get here.
Right.
Go back to the name window above build name. Right above it. Yeah. So that one is doing a default, but it's doing something useful, saying if you haven't provided it anything before after EIG
is the name. Yeah.
Is the name.
Yeah.
Oh, you're getting rid of the EIG there in the copy. Okay.
Because it's like there's a number of places where we just try to shorten some of the stuff that goes into the log because there's parts of the string that are the same over and over and over and over and over again. It's just a waste of reading space.
You need the EIG : prefix in your
Perl lib
class namespace for safety.
Yep.
But you don't need it in the stringified form.
Exactly. And then here's the make.
You don't want to use that for serializing if you're ever going to rebuild it.
Correct. But that's why it's a name and not a self or something like that. And here's make call. This just knows this is just a default method for calling client. Client. So if the Google Apps endpoint, if a Google Apps endpoint wanted to make a client method call, it does make call with a class name. Now this could either be so this is one of the at this point this could be a string, which could be the name of the Google client method to call, or it could be an instantiated Google client method object. 85% of the time, it's a string here. And inside of call, we'll say, oh, we got the string, so let's instantiate the client method and then use it. Sometimes we want to actually instantiate the method in advance. And the only times we want to do that is if we want to cause the validation to be invoked before we do something else. And usually that's the only places we've done that so far are at the highest level account create. That's like the first post you might call. So to create a new certificate, to create a new Google Apps for Business account. We have found it useful to instantiate the method objects in advance of making the call so that the validation happens, so that you don't put a bunch of stuff in the database that you then have to roll back because you're never going to be, if you're creating a new account and some of the stuff you're going to have to call up to Google is not going to ever work because the inputs are invalid, there's no point in creating those entities in the database. So we create the method objects earlier than we might otherwise so that we can have that validation checked. And we can go ahead and return the validation errors to the user before we go ahead and put stuff into the database. For most of our endpoints, we're not putting stuff into the database before we make the call, so there's no reason to create the method separately. But we needed a hook to be able to do that. And I guess it's, everything else is pretty much subclasses and special cases and stuff like that. Does anybody have any questions? Or anything you'd particularly like to see?
How much experience does your team have with Mojolicious to begin, and is there like any learning curve for that?
Almost none.
Yeah.
One of us had done a couple of little toy apps on her own time. Lisa had done a little bit of toy apps on her own time, but no real production experience with it. The learning curve for Mojo was very low. There's a couple things I don't necessarily like about Mojo, but and I'm sure Mojo purists would tell me that there are some things I could do better in the stack to better integrate with Mojo more naturally. But to get the basic stuff you need out of Mojo, which is a lightweight a lightweight controller for web services, was very, very little load time. It was very, very simple.
I've played with Catalyst before, but it was definitely very complicated. But there was a lot of documentation out there, and the documentation on Mojolicious seemed a little more sparse. Just curious, what resources would you recommend if you're trying to?
The tutorial. I mean, basically, it's the tutorial. The biggest thing we had is we're not using Mojo Lite, we're using Mojo because we need a little bit more control over the routes.
Mm-hmm.
But most of the best startup documentation is for Mojo Lite.
Okay.
So you kind of have to skim through Mojo Lite and then read the next step doc, which is like how to go from Mojo Lite to Mojo.
And that's a typical path.
And that's a typical path. I don't think I spent more than a few hours reading the Mojo docs before we were doing, there've been a couple of times where I've had to dig down into the documentation. But for the most part, I found it pretty easy to find what we wanted in the Mojo docs. The one thing that we had trouble with is, and this is one of the things that kind of irks me about Mojo. I understand sort of what their argument is, but like Mojo rolls its own for everything. Mojo has very few CPAN requirements because it re-implements JSON and re-implements pretty much everything from scratch internally. Which makes me a little nervous because it means, is the tool that's re-rolled inside of Mojo, it's pure Perl, going to have all of the same features that the CPAN library that does the same kind of thing has.
Flip side is you won't get all the bugs that are announced to the world as being security vulnerabilities in the well-known libraries. You get different ones.
You get different ones. And if we were writing a much more lightweight web service, I expect I would, and this is sort of where I was kind of arguing for Dancer over Mojo, then the fact that Mojo doesn't bring in much of CPAN at all, if any, is kind of a win, right? Because it doesn't have a lot of CPAN dependencies, it doesn't bring in a lot of stuff, it gives you a little bit more controlled stack. Well, we're using a whole lot of other modules. We're already using Moo. We're using all kinds of stuff that bring in other kinds of stuff.
Which means you need to be controlling your module stack anyway.
Which is why we use Pinto.
Yeah.
So we have full control over when our modules get upgraded and to what versions and from where. So our install processes, all have the CPAN mirror points to our private Pinto repository. The one place I had trouble with Mojo was actually in the renderer, where I wanted to be able to have a little bit more control over whether or not we did UTF-8 encoding based on the car set in the accepts header, in the content type header. So in the serializer, we fall back to Mojo's default unless and we just let Mojo do its internal thing. But if the caller does not want UTF-8 encoding when you convert to JSON and the serialized response, then we had to do JSON and set that part explicitly. And I really just like if you use JSON at all, it's usually like to JSON data structure UTF-8 and either you have the UTF-8 one parameter or you don't, and that controls the thing. And I just wanted to find out how to let Mojo do its own internal thing, but give it that fucking UTF-8 on or off Boolean. And there isn't a way. I couldn't find any way to tell Mojo to not do it or to do it. I couldn't control it. So I had to bypass Mojo for that. That's the only place, though, that once we learned Mojo a little bit, that's the only place it pissed me off.
That's not bad.
So yeah, I mean, I could live with it. I spent, 45 minutes or an hour and a half, whatever it was, reading docs and trying a few things. When it didn't work, I just said, all right, screw it. I'm just going to do it myself and move on. Anything else?
So you have the Nginx reverse proxy.
Yep.
Does Mojolicious come with its own sort of server that listens on a port?
Yep.
Okay.
So as a matter of fact, it comes with a bunch of different servers.
Okay.
You can plaque up. You can use its own internal lightweight. I don't even know what it's written on, but it's Mojo's little pre-fork web server engine. It comes with Hypnotoad out of the box, which is what we're using in production.
Mm-hmm.
So on my laptop, and that was one of the other things. Like we're using Git, and this was a greenfield project, so we had no legacy library support requirements and all kinds of that stuff. So when we set out to design this, we wanted to make it so that I could work and do commits and stuff from my laptop even if I was offline. I can work on my laptop and test against Google. I can actually start up a server. I can do, I do the Mojo script pre-fork. I can start up the Mojo server on my laptop and make curl requests to my own server as if I was a platform, and it'll go out and talk to Google, and it will insert stuff on my database on my laptop. Even if I can't talk, even if my entire data center at work is offline, I can continue to develop and work and test and commit. And then when I get back to my data center, I can push it. So, that was one of our.
What about the pieces that need to talk to the database?
I run the database right here. So that's I have a developer config file with how to connect to the database that I'm running on my laptop. And so my developer config overrules whatever's in the server, instance default configs. So when I'm running it on my box, what it basically does is it looks at environment user, and we have a repo for developers. And so it looks in our developer repo path, and it says, do I see a developer S. Quinlan? Do I see a match to my environment username? And if I do, is there a config file in there? And if there is, read that in and overwrite any defaults with what I found there. And so my developer config tells the stack how to connect to the database running on my server, rather than trying to connect to someplace else. Which is great because I can test. One of my coworkers is having trouble debugging something, and I want to run my stack, but against the data, and I want to use her test users. Well, if her laptop will allow my laptop to connect to her, if she opens a hole in her firewall for my SQL's socket, I can change my config to connect to her database server and run my server, use her test users, look at my code dumps, and help debug what they're working on using the stuff in their database just by changing my developer config. If we have an issue in production and we need to hot swap to a different database data center, right? Both our master and server databases have gone down, and so we can't just do the usual switch there. Like we can't swap to one of them. We can't do the IP routing. It's like the whole data center burnt down. I can change a config and point to a MySQL database that we've spun up off of backups someplace else, and we just have to change the config and restart the servers, and it connects to the right place. Actually, we don't even have to restart the servers because it'll get that connection information dynamically, but whatever servers are active will, whatever children are active that have already read it would bark, so we'll just restart it just to clear the cache.
Mm-hmm.
So
Cool.
one way you might sum up the high-level objective for this project is that you wanted to reduce the end-user pain for accessing a new third-party service. It'd be about the same as what it would be to access a new table in an internal database.
Correct.
So basically all the authentication, all the methods for dealing with it are there. The only thing new is the new data that you have to deal with.
Yep. Because basically you're just saying, client inputs, what are the outputs? So it's basically, it's kind of like a database table. I'm going to insert some stuff, I'm going to select some stuff, and then I'll do some things. And, all of the stuff that's other than, put some data in and get some data out, is all the stuff that's going to have to be specific to you anyway, and the rest of it is like really you're giving it a data structure, you're getting back a data structure, and you have a string that's the thing you want to call. And all the rest of it, yeah, you don't have to know how all of it works. I mean, a developer on one of these platforms, you know, a new developer just came onto the company on one of the platforms whose job it is to add some UI feature that requires getting some status from our APIs, you know, from the Rosetta API. They don't have to know anything about how the service bridge works, or whether we talk to Google or not on that call, or how to use LWP, or any of that stuff. They just, you know, somebody says, here's the client, you call this function and give it some args, and when you get back, you're going to have to change this page based on what you get back. And they can just friggin' make that call. They can have that one friggin' function call, which behind the scenes is calling us and we're calling Google. They don't have to know any of that.
And it can be in whatever language
and it can be in whatever
platform is using.
Exactly. Exactly.
Do you remember much about the DXS project that we worked on?
The DXS? You know, when
CIDC.
CIC, yeah.
And the parallels between the architecture for that and this.
The lessons learned. Well, I mean, it's when I came onto this project, and one of the reasons it sort of excited me is I've done stuff that was almost this a number of times. We had that project that we brainstormed and we wrote some docs on. You guys sort of got off the ground. I'd done a couple of other sort of, in our legacy platform, I'd written 2 other interfaces to third-party APIs that I had tried to fit into our legacy platform with the limitations of the libraries that were available on the legacy platform. And so when we started designing this, I had the good fortune of having a fairly extensive wealth of experience integrating with other APIs, and the kinds of things that I thought you could generalize and make reusable, and how you could tool it up. And so a lot of our first week on this project was me basically going to Lisa and going to Ryan, the 2 other main developers on the team, and going, all right, well, if we do this, and and we just had massive whiteboarding sessions where we would get together in a room on Skype or whatever on a Hangout, and we'd brainstorm for 2 or 3 hours, and we'd protocode stuff up, and we'd write stuff on a whiteboard, and we'd go off and code for a day, and then we'd hit the next stumbling block, and we'd get to bed, and so it was just it was an incredibly rewarding. It was exhausting, but it was an incredibly rewarding couple of weeks of, we knew where we wanted to get to, and we knew we could choose whatever tools and whatever architecture and whatever. Like, we had no restrictions, and so we could all take the lessons learned and the best practices, and we could look at other people's experience on the web, and we could look at the stuff we've done before. Damn it. And really try to come up with a design that would be long-term flexible. That was a huge one of our goals, because we knew if we did this well, if we succeeded in meeting the completely stupid, unrealistic goals that the enterprise had put on us, if we succeeded, then we'd be allowed to do this again for other things. And we wanted that. We wanted to be able to have a stack that we liked working on, that we could then continue to add value to the company and really return value. Like, it's a win-win for a developer. I'm getting to work on stuff that's cool and that I like. Thank you so much. I'm getting to work on stuff that I like with tools that I think are cool, and I'm able to return a value to the company in a way that I find rewarding. I mean, it's fantastic. And so we really wanted this to succeed, and we really wanted it to succeed in a way that we knew that when we got the next project and the next project and the next project, that each provider we integrated with would be easy until we hit one that does WSDL, and so it would get easier and easier and easier every time.
Hopefully that never happens.
Hopefully that never happens. I'm not placing any bets on it not happening eventually, though.
Being able to choose stack pieces that gave you high leverage, work nicely together, and have good user community, user docs.
Yep.
Enabled this.
Yeah, enable and being able to go onto a mailing list or a chat board and say, hey, I'm having a problem with X. I've tried Y and Z. Can anybody help me? And not have them go, well, what version are you using? Oh, this version. All right, well, that's 12 years old. Can you upgrade to something newer? No. You're out of luck. Like, you get really tired of that, of that cycle. So being able to go and, having gone to a lot of conferences and, there's a lot of the maintainers of some of these libraries that I've met a number of times at conferences, so I can kind of poke them a little bit and say, hey, this thing's bugging me, and I'm like, I'm a little stuck. Can you just give me the right pointer to get past this hurdle so I can move on to the next problem? And literally now, like, we just started doing the SSL project last week. It literally, we were blocked for a number of days just because we couldn't quite figure out how to encode the certificate signing request in a way that their platform we were integrating with would actually decode and allow us to make the request. And we were a little slow getting responses from them. But it was probably only about 2 days of work to get the entire framework up and running and stubbed out, and making authenticated requests to their platform and getting responses and parsing the responses. And like, it was 2 days of work to have the entire framework for a whole nother third-party integration stubbed out and actually making requests and getting responses. No, we were stuck for a few days, like I said, on actually getting them to accept our request and return a response that we could then move on to actually generating certificates. But it literally, so like when we start up a new project, we need a new server instance, and that server instance gets a Mojo subclass and a router subclass. And it needs the configuration file for the Mojo configuration file for that instance, but that's largely just copy and a couple of edits. It gets a top-level subclass of Rosetta for that thing we're doing. And then it gets an API subclass. It gets an API module which uses the endpoint role. We do the data. So we create the 2 Mojo subclasses. We create this endpoint class. We create the database and run DBIC gen schema, which generates the schema file and all the DBIC schema stuff. And then we create a client API subclass and a method subclass. And that's it. That's the entire framework you need to be able to start writing stuff. All of these methods here are actually the endpoints. So those are the provider endpoints that we're going to implement. So I had all the API docs. So when I stubbed out for SSL support, I literally went through the API docs and I created a file for every remote endpoint that we might have to call against. And I put in, basically in each, so in each of these endpoints.
Were there no existing CPAN modules to interface with Google Apps or Komodo?
That's actually an interesting question I forgot to talk about, but I have to plug in before my laptop dies. So Google has this massive library of, thank you, has this massive library of clients in all kinds of languages, open source clients that talk to Google Apps, that they have sort of validated. There was not one for Perl.
Yeah, they tend to favor Python, it seems, for apps.
They had Python and Ruby and Java and C# and 3 or 4 other things, but no Perl. There was a project on GitHub to talk to Google Apps, to the Google Apps API, but it was a public Google Apps API client, not the reseller Google Apps for Business one. So it has different authentication. But we actually did get some clues from there. And when we had the technical kickoff with one of a couple people from Google came out to our offices for the technical kickoff, we had 2 days of meetings. And one of our biggest stumbling blocks getting started was we were just trying to do curl and have a couple little test scripts as proof of concepts that authenticated. We could do OAuth authentication, but we hadn't gotten the friggin' reseller authentication working. And so we actually spent about an hour or two with one of the Google devs. He's not a Google developer, but he's the engineering sales guy. So he's got some developer experience. But he had a little bit of previous Perl experience, and so we sat there with the one thing we found on GitHub, looked at it, looked at the docs, figured out, sort of sitting down with him within the room, how to create. So we found the JWT module on CPAN, and we figured out how to properly sign the auth request. So basically, the way Google Apps works is you get this auth, you have this token and a private key, and you create the signature for an auth request, and you get back an auth token, which is good for 1 hour, which you can then do whatever you want with. You can make whatever calls you want with. He actually contributed that JWP piece back to that GitHub project. I don't know if they've pulled it. They've submitted a pull request for that change. We would like someday to be able to make our Google Apps client stuff, be able to contribute it back out. The company kind of supports it, but it's a little bit embedded in our stack. We tried to write it in such a way that most of the framework isn't, but it's written sort of expecting to sort of be, it expects to have a logging role and an error handling role and a DBIx. Like, it expects a bunch of stuff that we provide. So we could pull it out, and there's example code of how you sign a request ticket. I mean, like, all the code that somebody would need to write an API for Google would be there. But it sort of all needs to be refactored into something that's much more generic. It doesn't sort of have our support infrastructure. Maybe I'll do it on vacation while I'm on vacation. I thought there was something else I was going to answer as part of that too.
You wouldn't be able to base your implementation off of the public one.
The public one, yeah, the public one would not do what somebody needed to do with Google Apps for Business integration.
No, but if you pulled your code out into a new module on CPAN and then used it as a dependency.
Yes, potentially we could, and I would like to do that at some point. What I might try to get permission to do this winter is get permission to put our Google client-specific portion of our code on a GitHub project, and then invite some people to come in and help me refactor it into something that can stand alone.
Like the guy who set this up.
Yeah. Say, look, we've got all the bits are here. Everything that you need to talk to Google Apps and get the JWT and all that's here, but it's doing self-trace and self-debug, and it's doing config this to get the. We just need to gut all of that sort of infrastructure, our Rosetta infrastructure stuff out, replace it with a couple of constants, and make it stand alone.
And then make it such that you can extend that or embed that.
So you can pull it out.
So I can pull it back in.
Are there any?
I would be less worried about that.
But if Google adds some new functionality and somebody else adds that to the public one,
unless Google changes how it authenticates and all that stuff, there really isn't a lot of. So it's sort of what I was getting ready to show you here. So the way it works is, so the client. So the client API. Am I on the right one? No, that's Komodo. Google Apps. There it is. Oh, it's not even there. Oh, I know what I want. It's the method. Right, so build host. So basically what we have a method base class, which all of the client API methods subclass off of, which know how to build the host, so that's the host it's going to call to. And if we look at a method, the method defines its endpoint. Right, so basically each method just knows what its endpoint is. It knows how to build request args. So this is basically when you create an instance off this method, there's all of these lazy attributes that when somebody goes to when our client infrastructure goes to make a call, it basically asks the method, "What's your endpoint?" And we actually have it actually does URI. So we use the method URI creates a URI object, which does a make abs based on the host attribute and the endpoint attribute, right? And then we give that URI object to LWP user agent to make the call, which gives us all of the query encoding stuff that we want. It also gives us some nice features. Doing it that way also allows us to, if something needs to overload behavior for its subclass, by adding something to a base class thing and wants to add a query attribute, we can do method URI append to query key value, and it puts it into the URI object, which will get passed automatically to LWP user agent for the request, and does all the encoding. Like it gives us a lot of that stuff for free, and gives us a way to add stuff from whatever point in the chain we need to. We do that for authentication, for example. So authentication's the same everywhere. I shouldn't say authentication. Authentication is the same for most methods for a given provider. But there might be exceptions. So any subclass in that class's chain could say, hey, here's the default authentication, which is going to do query append and some stuff into the method object. But the subclass for specific methods could say, you know what, we can't use the generic authentication for this provider for this method because it's some special thing. It's got a different API path. It's a different third-party provider. It's got whatever reason. So it does some slightly different authentication. And we can just sort of do that as an override of the default authentication method. But this is basically it. So we have for a given client API method, we have a build endpoint, which is the path that it's going to call in the remote API. If it wasn't a post, there would be a build request method to set it to get or put or delete or whatever, but it defaults to post. We have build request args. When you create a method object, you give it input args. If the input args are exactly what you want to send to the endpoint, you don't have to do anything else. You don't even need to have this because the default request args are the input args, so just pass them on through. But this is where we do the translation. So the input args SSL format. Let's see, is there a better example down here? Yeah, here. So, we have a Boolean on one side, but we want a yes/no for this endpoint, and so this is the name of the that's the name of the argument we're going to send to the remote API, but internally that's the name for it. Excuse me. So build request args basically just is where the translation happens from our internal nomenclature to what we need to send to the remote API.
Yeah, and it's laid out declaratively with ternary operators.
Yeah.
That's nice.
Yeah, I'm really very proud of this project. I will point out, so when we started on this project, we had what we thought were some crazy time constraints.
Did you finish early?
We did not finish early. We did not. Let's see if I can find this. So this is from Dennis James at Google. We had 6 weeks basically to finish our implementation of the MVP portion of the project. And we've added a bunch more endpoints and stuff and features since. We had 6 weeks, 3 sprints to do the main MVP, meet the MVP requirements, and that gave us 1 sprint to do debugging and as soon as we were still brainstorming how to write Rosetta and what the framework would look like and what tools we were going to use, and the platforms were already asking us for the API documentation. And we were like, we haven't even made a successful call to Google yet. You got to give us some, but they had the same deadline as we did, which was crazy, right? So they were trying to implement stuff against our API before we'd even figured out how to talk to Google yet. So we were literally updating the API docs every day as we solved problems and worked through design decisions and stuff like that. So we actually color-coded our API docs. And if it was gray, that was, we think this is what it's going to be and what it's going to take as inputs and what it's going to return, but it's not set in stone, don't depend on it. Like the whole thing could change, but that's our best guess right today. It was green when we actually had a protocode of it on a server somewhere they could hit. And that meant we actually had some working code that talked to Google. We maybe had bugs, we maybe had, we hadn't decided what all the arguments in and out were going to be. We hadn't discovered what all of the conditions that we were going to have to operate under were going to be. But it was a pretty good first guess. So it was green, and that meant they should just start actually testing against it. And then it turned blue when it was actually released in its final beta test version, and we didn't expect, once it was blue, we didn't expect any major changes. We might add some optional arguments and do some stuff like that, but it should be pretty much set at that point. But that was the only way we could sort of iterate on it. So we were working under that pressure. We had like I said, most people that start on a Google Apps integration project, partner with Google, are using a client that somebody else has already written. They don't have to solve the authentication part. They don't have to figure out how to compose and break down how to compose arguments to send to Google, how to parse the response from Google, how to interpret HTTP codes from Google, how to set errors based, all of that stuff was written for most people that start on this project. We didn't have any of that bootstrapping. We had a crazy deadline. And this is why Perl is freaking awesome. With all of that craziness, 3 developers, functionally 3 developers, 6 weeks. We blew away every freaking person that has ever tried to do this with Google. By an order of magnitude faster. Not only did we integrate with Google faster than anybody else ever has, we have 3 completely separate business units using Google marketing on time. Faster than anyone has ever done it before.
Yay, Perl.
Perl rocks. Because all the tools we needed were there, because it was easy to design, it was easy to reuse the code, it was easy to set all the stuff up we needed and handle errors. Everything was there to bootstrap it up. We were just solving problems with figuring out why is Google giving us a 403 here?
And Tim Tody gave you a choice of
Yes.
this, that, or the other server, this, that, or the other database abstraction, this, that, or the other class system, so you could pick the level of help you needed.
Yep.
Without biting off too much.
Yeah.
Do you have any information on what these other projects have used, just for comparison's sake?
Most use Java. Which it makes me a little less, I should brag a little less about having beaten them in speed.
Well, it's good to know, right? Because enterprises all load Java for whatever reason.
It's
You can
the
say, hey, don't that.
It's the programmer full employment language.
Exactly.
The enterprise, if you're lucky, they want to Java. It's worse. It's
Yes.
I was in college recently. They're just pumping out Java guys.
Mhm.
Yep.
That's all they want to push.
Yep, because there's marketing money and there's funding from, there used to be big funding from Sun and places like that to teach Java programming, and
My intro to the programming class, which should have been C, was Java
yeah.
and Python.
Yeah, no, it's a whacked ecosystem. I mean, it really is. It's completely out of bounds. Now we'll go off into a little Java bashing tangent. But I've been at 2 different companies that have tried to bring in Java because they hired new management, new executives, and we had some legacy code, and they wanted to do something newer and sexier and more stable and more enterprisey or whatever, and so they wanted to re-implement some chunk of the code in Java. Both of those projects have failed miserably. One of them brought on a high-end Java consulting company, brought on a high-end, years of industry experience, enterprise experience Java architect, and it took them 3 years and 6 Java developers to not quite replace 1.5 Perl developers. Like millions of dollars. And after 3 years, the product that they had looked like a semi-decent, not quite feature-complete CSS update on the old product. Like if you'd actually just hired one good UI guy, a little bit of refactoring on the Perl code in the back end, and let the UI guy go to town on ripping the front end apart, you could have gotten the same thing with probably one guy in 6 months. But 6 Java developers and millions of dollars 3 years later.
Mm-hmm. And if you're an executive, you want to make your department bigger.
So that's my Java experience. Java was actually one of the first programming languages I started to learn a very, very long time ago. And then I met Perl and never went back. And nothing I've ever seen in practice in industry has ever convinced me that, like, you could convince me to do Python maybe. I could do Ruby. I could probably be happy doing Ruby development. If not Rails, but Ruby development I could probably But Ruby development I could be happy on. I've played with Ruby some. I could never, like, I would retire before I did Java. I'd go back to construction.
I used to in school do programming competitions, and Perl was actually not allowed as a competition language because it was too damn efficient. It was just too good. You'd have an unfair advantage over the Java.
Wow. Yeah, exactly. You know, so
that is a beautiful.
I mean, they could just say no CPAN.
It's the ICPC program, International Collegiate Programming Competition. And if you look at the history, they used to be any language you wanted. And one guy entered the competition who was good at Perl. And after that, because he kicked everyone's ass, they were like, okay, no more Perl.
Yeah, I don't know how much stuff in projects like this and everything. I don't know how many things. Because I started out in bioinformatics and writing a lot of command line code programs, I do a shitload of proof of concept work on the command line. Like I just start, Perl minus M this, minus M that, minus M this, minus LE, shell out to curl, whatever, call JSON compose. I do all my proof of concept as a command line. And when it works, and I can get a data dump, or it's like making a call, and I get there, it's like, all right, now I know what I'm doing. Let me go write some real code. But because I can do it so fast.
Can you show us some example code that uses JSON schema?
Yeah. Let me start sharing my screen again. All right, so here's the JSON schema file for Google Apps. I thought I started sharing, sorry. No, didn't click the right button. There we go. Right, so account subscription plan put. I'll tell you right now, I can show you the code in a second, but basically this means the class is EIG Google Apps slash API slash account slash subscription slash plan. So when somebody calls the endpoint account subscription plan as an HTTP put method, this is going to be auto-generated as a method name based on that class name that's being called. And there's going to be code that's going to say, give me the schema that you want to use to validate the inputs to this. Base schema is from the subclass. That's basically the wrapper that any JSON schema block needs, right? It's just the schema version and all that kind of stuff, the description. And so we create this hash ref, or this hash rather, that has that information that's the same pretty much for everyone. Our base schema description basically just does caller to get this subroutine name and stick it into the description. That's basically all it's doing up there. And then there's the properties, and so this endpoint is actually only has one required argument, which is plan name. It should be a string, and it can only be one of those two values.
Yeah,
right.
How often you pay Google.
Exactly. So that's what the schema for that endpoint is, right? So it's a put, it's a plan, and it's a put. So this is to change the plan you have now. So basically, I can tell you, looking at this, that this is a call to change whether you're paying monthly or switch from monthly to yearly payment for your subscription plan. Right? That's the validation for that call. There's the renewal put. There's the valid arguments. Right. So these are just the different schemas, and let's see if I can find. Here's one. Because this is just returning data structures, there are 80 million places in the APIs where you have to have a domain, or a domain is a required argument, and the what a domain can be is the same everywhere. So there's a little subroutine that returns the data structure for what a domain is in a JSON schema. So we can just call that all over the place. Let me see if I have an example of. Oh yeah, here. So the account user put shares a lot of basically the same schema as account user post. Basically, there's a user object, right? There's some thing. We can scroll back up and find it. So this gets that schema, and it deletes the email and the password as being required because it's a put, so you can't change the email. When you post, you're creating an email. You can't change it in a put. And the password isn't required because you can change other things and not change the password. We update the description. That's really just so that when we see it in the logs as a dump, we know which thing was called, and we return it. And so this is basically reusing a slightly changed version of something else. And this is why we switched from the JSON files, the actual JavaScript object notation in a file, to this Perl data structure, because once we made that switch, we could freaking reuse the hell out of stuff. Right? So this account post uses all four of these other schemas from other endpoints. It's largely the same. So
Can you note the reuse in the parent schema that you change this, you can break this
Everything.
thing?
No, we probably should, but this is all in one file. So if I change this, I just grep for that, and if it's anywhere else in the file, I know I have to go account for it, because all of the JSON schema definitions for Google Apps are in one file. All the JSON schema definitions for SSL are in one file. The must domain and stuff like that come from a parent. It's actually just a base. It's not even a parent class. It's just an exporter. It's just a lib that exports into this namespace. Because not everything has to be an object.
And now can you show some code that makes use of this?
Yep. All right, so this is the JSON schema base class. Sorry, the JSON schema role. So anything that does basically the endpoints and the client API methods will consume this role. It knows how to store its schemas and its file and its target args. But it has this. So anything that uses this role will automatically, during the build phase, so during object construction, or actually technically right after the object is constructed, but before it's returned to the user. So you have self here is a fully constructed instance of the class, but it hasn't been returned yet to the caller.
So it's like an after on the new.
Exactly. Yeah, exactly. And so it does self get JSON schema name. Ooh, can't look up there. There's too much lag. So that has to be implemented by the consuming class. That's just a trace output. So the name is basically, and I'll find an example of where we can post the name, but that's that account subscription plan put, right? This is basically just something that's going to return that name. It then gets the target args, right? By default, it's going to look for the self request args, right? So you see here it does self target args. Target args is just the attribute name, which defaults to request args. But some other consumers may not want to validate request args. It might want to validate a thing from database or whatever.
Okay, but you're doing target args equals JSON schema target args.
Yep.
But then you're doing the schema validation on self target args, not on my target args.
Target args is an attribute name.
You've got a my there.
Yes, my attribute name equals this, right? So build JSON schema target args, right? So JSON schema target args is the attribute. This builder is going to return request args by default. So this builder can be overridden in a subclass somewhere or in a consumer somewhere. But if it isn't, self JSON schema target args. So when I get the value of this attribute, it's going to set this variable as request args, right?
Yeah. Okay, that's indirection.
It's indirection, right? And it's basically just so that the attribute that contains the data structure you want to validate can be overridden in subclasses.
Okay. Yeah.
And so we just call self JSON schema validate with the name of the schema we want to use and the arguments. We get out the data structure we want to validate. So here's JSON schema validate. If validate wasn't given a reference, then it loads the schema, which is basically it's going to call load JSON schema, which is going to get that. It's right here, right? Yeah, load JSON schema. It's going to see if it's already cached and return it if it is. Otherwise, it's going to say, can the schemas file, which is the file I just showed you, right? Can that file can that class name, does it actually have a method that will of this name? And if it does, so we don't blow up, it calls it, and it returns that data structure. So the data structure we were just looking at, definition here, is what's returned. So in that file we were just looking at, let me just. So here we return a reference to this schema def. So this definition is that reference that's returned, right? We then call JSON schema new with that definition, and that gives us the JSON schema object, which knows how to validate. We stash it just so we don't accidentally have to reload it. There's very few calls, I think, that actually end up reusing the same one in the same code path, but why not? Yeah, so this loads it up. So now so schema here is a JSON schema object with a definition already loaded. If it isn't, it's because there wasn't one defined, right? So if when we said, does the JSON file have a schema method matching that name, right? If it did, we get back a data structure. If it didn't, then schema is empty. And we return 1. We return valid. Because if there's no validation defined, then there's no validation required, is our assumption. So we auto-pass if no schema is defined.
Okay. That could be trouble later.
Yeah. And if it ever is, then we can change that to return 0, and then go write a whole bunch of empty stubs that return empty data structures. and we'd have to be, in order for it to be different than having the default be to return an empty data structure, we would have to explicitly create.
Right, but you might want to audit all where you're getting those debugs to know if you're in trouble.
That's just a trace statement. All right, so here's schema validate. So validate is actually a function of the JSON schema object, a method of the JSON schema object.
Schema validates the data.
So the schema validates the data.
That line's exactly what you want to see.
Yep. And then the way JSON schema validates is weird because in Boolean context, this is true or false. So if it is valid, it's true. If it's not valid, it's false. And if you print it, you get an empty string. But if you call errors on it, it gives you back a stack of errors, which was a little confusing when I first tried to figure it out.
That's very Perlish.
But yeah, so basically they've overridden the behavior of the object in Boolean context and string context to return empty string, but it's still an object. It's still actually an object.
Yeah, and it gives you something that's effectively an iterator.
Yep. And then here, so if there were errors, we loop over it. We make a data structure, and then you can see here we call add error. And like you've seen everywhere else, all over the place we do return if has errors, or do something if has errors. So this is basically how we manage errors in Rosetta. So if it fails validation, it puts in a whole bunch of errors, and those all get bubbled up.
And if you add to errors, you don't bother doing a debug?
Right, because actually, if we went to the error handler, when you add an error, it actually throws an error level log message.
So the add error is doing a log message
as well, automatically, right?
As well as creating something that can go in the response. Okay.
Yeah. So basically, every time you call add error, it creates an error object, which uses that information in the creation of the object
and logs that as well as sticking it in the stack.
Exactly, in the stack of errors, right? So potentially
minimizing doing things twice.
Right.
Nice.
And potentially, like, in your call path, you might end up getting back to complete response and sending back to the caller. There might be 6 errors. Hopefully you don't get that many errors generated before we decide to catch it and return. But we could be in a section of the path where we want to try a bunch of things and accumulate all the errors because it's useful for the platform to know all the things that are wrong. Validation being one of them. So we might have 4 validation errors, and that's actually 4 error objects that we could add. And so all 4 of those errors are going to get returned to the caller.
If your phone number and your credit card are both invalid, let's tell you.
Exactly. Yeah. And so we treat all errors generated in the stack the same way. So we push errors onto the stack and then return all the errors to the caller.
And then finally, can we see a class that uses this role?
Sort of. Because it's a role, yes. I mean, yes, you can.
But it's effectively invoked by magic. You just say it has the role, or the base class has the role, and everything automatically validates by magical name sameness.
Right, so here's a class. This is the endpoint. This is the SSL API endpoint base class. So it uses JSON schema.
Why does it have the roles there? Doesn't it inherit those roles from its base class anyway?
It inherits error handling, transaction handling, DB access, cache. It inherits a whole bunch of roles. But these roles, endpoint role is specific to endpoints.
Okay.
So it's not going to inherit that from anywhere else. And JSON schema and HTTP status are only used by endpoints and client APIs. So
those 2 weren't on the master Rosetta.
None of these, exactly. None of those 3 were on the other one.
Okay. It just looked like everything and its brother was there.
Right. And like I said, the
kitchen sink was missing 3 spoons.
Exactly. Yeah. I'll show you the whole step. So, and actually, I want to move transaction handling from the base class to here because this
I remember you saying that.
Because nothing else uses it other than the endpoints and the client APIs. So, here's the overload of build
So-
client.
In which case, those two things may be extending some base class that has those three roles.
Yeah, but
If you want to be purist.
I suppose I would rather have fewer steps in the hierarchy and just load it in the three roles where I need them. I'm all for code reuse, and
If a third thing ever needs those exact three,
then I'll consider it.
right? Two is an allowable number. More as a special case.
Anyway, sorry, yeah. So here is...
And here you're chopping EIG SSL API off.
Yep. So here we use JSON schema. This doesn't have a custom build, so it doesn't have to. So it's going to use JSON schema's build. But I could copy and paste it here if I needed to, add stuff to it or whatever. So here, get JSON schema name. Right, it gets a ref of self, so this is going to be whatever endpoint class is inherited from this. It's going to take EIG SSL API off of it because we don't need that. That's going to be the same for everything in this namespace. Substitutes the : with the underscore and adds underscore with something like account subscription plan put. This meant that the class was account : subscription : plan. That was the class name that was being instantiated.
And at lower cases for canonicalization.
Correct. Right.
And this enforces magic name sameness instead of requiring people to retype it in lowercase.
Right.
Is linkage to the JSON schema the only thing that you need that name for?
Yep. That name basically tells it which thing in the schemas.pm file to call to get the definition you're going to use to validate.
So the reason why I had you go through all that because I wanted to see how it varied from the approach that we took on the DXS project.
Oh, right.
We solved the same problem a different way on that project. So on that project, we had the model class done in Moose, similar to how you've done it. Instead of using JSON schema as the validation language, I think we used data validator as our library of validation rules. And then we extended Moose so that when you did has some object name, and then you have all the attributes of the object property listed. One of those was the validation rules right in the object definition. And that was also the place at which we defined the database field name that correlated to that field. So now you have this single object that had the complete definition. Say you were dealing with users. This one object defined everything you needed to know about a user. How to validate a user, how to get it into the database, what field mappings were needed to go between the internal representation and the external representation. And it was all in that one spot. So for any particular field, you had all the details about that field in that one spot, rather than spread across files, multiple hierarchies, that kind of thing.
Right, which is why we have the one schemas file here, so that all the definitions, not only for a user, but all the definitions are in one file, so that you can reuse that user definition. You can combine it into other things that might need to be able to validate the same, that might need to have a user in it as well. So like there's a couple of endpoints for the Google Apps stuff, there's a couple of endpoints that have to be able to validate that the user information is there. Because there's a couple different user endpoints that have slightly different variations on what's required for that endpoint. But then there's also the account post and stuff, which have to have a user as part of a larger data structure. Which is why we ended up combining all of those separate things into one file, so that it was easier to reuse. And then this just gives us dispatch by convention, by converting the class name into a method call. But also because it's a method, if any particular subclass of this ended up with a name that conflicted with something else, or wasn't sufficiently descriptive, or we wanted to have two different names under certain circumstances, we could actually override this method in the subclass to return something more explicit. rather than have the auto-generated name. We had one case where we needed to do that. But.
Okay.
Yeah, and this doesn't know how to do. It doesn't know the difference, the translation of the arbitrary things in this JSON schema to our database definitions necessarily.
I think that was great.
That was a long presentation. Well, thank you, everybody.
Thank you, sir.